Hi, I'm Tim Tyler and this is a video about universal agents. I'll also be covering the concepts of universal sensation, universal action, universal computation and universal memory. But first of all, a brief history of universality. Long ago, John von Neumann introduced the concepts of universal computation and universal construction in the context of cellular automata. Universal computation turned out to be largely equivalent to Turing completeness. It became a very popular and important concept. Computation universality eventually became widely shortened to universality in cases where there are enough context clues to understand the abbreviation. By contrast, universal construction suffered from some problems. It wasn't terribly obvious what it referred to in the case of irreversible automata, and it turned out not to map neatly onto the concept of being able to support self-reproducing creatures, as what was illustrated by Chris Langford with his self-reproducing loop. Today, I'll be continuing in the grand tradition initiated by von Neumann. However, I won't be working with cellular automata today. Instead, we'll be looking at cybernetic systems. I'll be introducing several new universal concepts. In digital cybernetics, there's the concept of an agent. Agents repeatedly accept digital sensory inputs and simultaneously produce digital motor outputs at discrete time steps. In this type of cybernetics, things like battery life, resource and storage limits, error detection and error correction are abstracted away and ignored. First of all, universal sensation. Universal sensation refers to the idea that agents can potentially experience and endure any finite sequence of sensory input symbols. They can enter states where there aren't any specific sequences that cause them to explode, shut down, turn their sensors off, unplug themselves, or otherwise cease witnessing. The agent should be able to attend for unlimited periods of time. Then universal action. Universal action refers to the idea that agents can issue arbitrary finite sequences of motor outputs. There is no sequence of motor output actions that they cannot perform. The agents can't bash their own brains in, they can't turn themselves off, sabotage their motor outputs, or do anything that might interfere with their motor outputs being generated. Maybe they can chop off their own actuators, but there must still be some level at which their motor outputs can still be detected. And then there's universal computation, and agents can also exhibit that, and that means what it usually does. And there's also universal memory. Universal memory is the ability to remember any finite sequence of symbols. And some of these concepts depend on other ones, and the dependencies are that universal computation depends on universal memory, and universal action also depends on universal memory. So those are the basic definitions. Why might one be interested in these concepts? Universal action affects whether an agent can perform destructive brain surgery on itself. Agents that can't do this tend to be immune from certain theoretical problems that plague intelligent machines, such as the wirehead problem. Then there's the issue of whether agents can learn arbitrary action sequences in response to arbitrary sense data and so become universal agents. The capabilities of universal computation, universal memory, universal sensation and universal action appear to be prerequisites for this kind of universal learning. I hope that these concepts prove useful in thinking about the possibilities for synthesizing agents. Enjoy.